Group functions are the multiple row functions which we call group functions, or we also call them as a multiple row functions. See, whatever the functions that you have discussed about in the previous classes, so that is your only the single row functions what we have used. Means when you are passing one argument to it, it will give one result per one row. Okay, so when you talk about a multi-row functions, it's basically that this gives you the one result, one row per set of rows, one row per set of rows. So how it works? See, in an employee table, you have a department ID as well as a salary which is being tracked in this. So when you say that out of all these values, if I ask you to pick a maximum value out of it, so you probably will look for all the values which are present and you say that maximum value will be the 24,000. So this is basically per group of rows you're actually getting the maximum value in the employees table is 1. So it is operated on a multiple rows and it is giving you a single row per set of rows. So that's why we call a group functions as a multiple row functions. So if you see, out of this, whatever we have, it is basically giving you the maximum salary out of this. So this is called as a multi-row functions, what you have. So when you talk about the another one, that is what are the different types of group functions. So it's basically that you'll identify the different aggregate functions: average, count, max, min, standard deviation, sum, and the variance. So these are all, we frequently use the sum, minimum, maximum, average, and the count. So these functions are also called as an aggregate functions or aggregated data. Whenever you want to aggregate the data, we also call the same functions. So we'll understand about the syntax. See, basically one thing that you have to remember is that when you talk about the average, let's say minimum, maximum, and then the sum, these functions will work for numeric data. So completely for numeric data, whenever you want to identify the average value, or whenever you want to identify the minimum value or the maximum value, you can always make use of the these functions. But if you check max and min functions, these things will work even for a varchar as well as a data type. So let me put it in this way. So max and min functions will work for numeric as well as the character data, and average and sum functions will work only for a numeric data. So let's put it in this way to make it simple. So whenever you are using it, you need to make sure that which data type you are using, and all those things you have to check it. So it is pretty simple, this chapter. So when you talk about, suppose let's say you have a requirement and your finance team has actually asked you to find out the total salary that we are paying every month to the employees. So how do you determine the total salary in this? So when you talk about it, let's say select. If I want to fetch what is the maximum salary that I'm paying to an employee, or the highest salary, or if I want to find out the lowest salary that I'm paying to all the employees, so lowest of all the salaries, or if you want to find out what is the average salary, so we'll use this. See, basically all your aggregate functions take only one argument as an input and then do it. So average of the salary. And when you talk about the another one, let's say the total salary that I'm paying, so I can also use the total salary from which table you have a salary column to determine. So that is nothing but your employees table. So this way it works. So before we work out it, let me show you an example again. So basically it will work on the group of rows. Suppose let's say if you have to pick the maximum salary out of all these records, it is 24,000. Minimum salary is 4,400. Sorry. And if you take the total salary, we'll basically sum up all the employee salaries here, and if you take the average, that sum of the salary by the number of employees which it is there. So this way we will use the group function. So when I try to find out this value, it basically gives me the maximum salary is 24,000 and minimum salary is 2,100, and average salary is very big decimal number 6461 and a big one. So can I round it to 2 decimals? Yes, you can apply the round function on top of it. So how many arguments the round function takes? 2 arguments. One is a column and another is a number of decimals that you want to. Now try to execute this query and see, now it is being rounded up to 6461.83. So this way we will use the employees table, from employees table to retrieve the data. So this is more on the this is a simple example about the using of average and the sum function. So as we understand, you can also use max and min even for a date as well as a date column as well as a character columns. So basically when you are doing for a date column, what happens? It will give you the, it basically gives you the, if you apply on a higher date column, lowest date is nothing but when you say 2003 is lower date compared to the 2015 date. So minimum hire date means oldest employee in the organization, and maximum hire date is a latest who has joined very recently in the organization, can be determined by using this query. So we have another function basically to understand. There is another function called as a count function. So you can use it with a star or you can use it with a count of column name. So both the ways you can use the count of star or count of column name, which you can both the ways you can use it. Suppose, let's say, if I have to determine how many number of employees are present in the my employees table, so it's basically that I use select and count of star from the employees table, count of star from employees. So when you try to use it, it basically gives you the number of employees present in the organization, or it's nothing but the number of records that you have in employees table, it will give you. So when you try and execute, observe the output here. So it is giving me the 108 rows, total number of employees in this, total number of records that you have in employees table is 108. So when you say that, let me use the same query with the column name and observe the output here. Concentrate here. So when I given count star, it has given me the 108 employees. So when I give count of commission percentage, let's say from employees table. So when you try to use this, so what it is giving me? It is giving me only the 35 records. Basically it is giving me only 35 records. So what is the difference? What happens when you use count star? What happens when you use count commission percentage? One very important thing that you have to remember is that whenever you're using an aggregate function, aggregate functions ignores the null values. Aggregate functions ignore the null values. So if you have a null value in the aggregator function, so it ignores it. So basically when you use count of commission percentage, it is calculating only the not null values. It is calculating only the not null values in this. Not null values it is calculating. So when you go and see, let me just give you the clear explanation here. So if you try to count the count of commission percentage from employees table, so why it is giving you only 35 records? If you see, most of the records are null. That means only 35 rows are having a column for a commission percentage. Remaining all the other columns are null. So any aggregate function, it is not only the count, any aggregate function, whatever you use, will ignore the null values. So if you have a null value, it doesn't even count that record. Okay, so if when you are using a count of commission percentage, it is counting, or you can call it as, it is counting only the not null values in a column. So from that, what you understand, it's basically ignoring the null values. And also, can we do it null along with the count to get the exact number of records? Yes, that we understand. So how you apply the NVL function. See, basically this will give you the only the not null number of employees. So when you use it, let's say if I have to use only the NVL function. So if I apply NVL function, what happens? I can convert that into a 0 or any other predefined value. So what happens? Every null value will be converted as 0. So when you try to count it, it basically gives you the 108 employees now, because you're converting a null value to 0, and your count is considering that value also when it is counting the number of records. So if you have a null value, it will ignore it. If you do not have a null value, it will take that value into the consideration. So that you have to remember here. So this is another example. I mean, maybe in another example also we'll see like how it works, applying the NVL function. So count function can also be used in another way. It's basically that, let's say if I use count of department ID, let's say from employees table, count of department ID from employees table. So when you try to use it, it basically has 106 records. So what happens if I apply the distinct here? So first it will eliminate the duplicate records in the department ID column and then count it. So when you try to do this, so basically this is giving you 11 records, which means you have only 11 distinct departments available in the employees table. So you can also use count function with a distinct as well. You can use that with a distinct. So what about the other one? Let's say you have a different other group functions. So how average function works with a null value. So similarly, if you understand, let's say if I am using average of commission percentage, so concentrate here. So what is the difference if you use with NVL and without NVL function on a null values? So if you use average of commission percentage from the null values, so it says that 0.22. So 0.22 is a value. So let's use the same function. So select, let's say if I use average NVL of commission percentage, comma 0, commission percentage, comma 0 from employees. So what is the difference between this function and this function? So when you try to see, this is basically giving you the 0.072. See, if you see the count of employees who are receiving the commission, it is only 35. So when you calculate the commission, average commission, it is calculating only for 35 employees, which is a wrong result. So generally, when you are calculating an average value, it's basically that you take the total commission that you are paying to the employees divided by the total number of employees. But if you see here, what is happening, it is taking the total commission, but it is considering, basically it is taking the total commission and dividing by only by the number of records which are not null, so which is not the correct one. So whenever, if you are applying the aggregate function on a null value columns, it's always good to understand, it's always good practice to check whether if you have a null values, forcefully convert them into some other 0 or something and then count the number accordingly or calculate the aggregated value accordingly. See, one thing that we understand from this is group functions will not act on a null values. That is a main thing that you have to understand here. So this is another example wherein you can understand the group functions which are having a null value. right? See, so far whatever the queries that we have written here, it's basically that you have what happened is like it basically that you have queried only the one record, maybe the maximum value, minimum value, average value, like this. What happens if I have to understand what is the total salary that I'm paying to each department? So see, when I'm writing a select max of salary, it is when I'm writing a total salary, it is just giving me the total salary of entire organization. Let's say you got another requirement wherein you want to identify how much salary I'm paying to admin department and how much salary I'm paying to let's say finance department, or how much salary that I'm paying to some other department. I want to identify according to the each department how much total salary that I'm paying. So it's basically how to divide the data into different groups. How to divide the data into different groups what you have. So divide the data into different groups. So let's understand now how can we do that. Let's say so far we haven't made use of the group by clause. Now we'll see. Let's say I want to identify the maximum salary according to the each department from employees. So group the data. Let's say group by, you have something called as a department ID. Let's say group by department ID, comma, max of, let's say I would like to calculate the total salary that I'm paying. So I'll give it as sum of salary. See, whenever you want to divide the data into different groups, we always make use of the group by clause. One thing you have to remember, does the where clause comes first or the group by clause will come first? Always the where clause. So you need to remember these clauses. First select, followed by from, followed by where. After that you have a group by, and next you have a having clause, we'll see this, and followed by the order by clause. So this is a sequence that you have to follow. First you need to pick the select, from, where, group by, having, and then the order by clause which it is there. So let's try to find out what is the maximum salary according to the each department. So basically, see, let's go back to the initial example before executing this query. See, we have different departments here, right? So you have a 90 department, you have a 60 department, you have a 50, you have a 80, as well as a 10. So if I ask you what is the maximum salary according to the each department, or the maximum salary, so for a 90, we can, by looking at this data, we can say for 90 it is 24,000, for 60 it is 9,000, and for 50 it is basically 5,800, for 80 it is 11,000, and for 10 it is 4,400. So basically you are dividing the data into multiple groups. So for each set of records your result is 1. So in the same way, if I execute this query, it basically gives me the total salary with respect to the each department. So when you say here for a 10 department you have 4,400, for 20 you have 19,000, so for 30 you have $24,900, and for 110 you have the 20,308. Likewise, it will divide the data into multiple groups for calculating the total salary. For calculating the total salary, we use this for this on a multiple departments columns. So that is the way you divide the data into different groups. So basically you have used this one. Does a group by clause orders the data? No, it does not sort the data on a group by column by default. It doesn't do that. So if you see here, I don't see where do you see the sorted data on a group column. I have actually sorted it by clicking on this column. I have sorted it just to show you. It will be easier for me to show you. That's why if you see this arrow mark which is pointing to upper corner, so which means that's a department ID which you have. Okay, so it doesn't sort the data. So this is basically giving you the total salary which is paid to all the employees. So now what could be the, let's say, one important thing that you have to remember is that the columns which are present in the select list, and not part of any aggregate function must present in the group by clause. This is a thumb rule you have to follow. Whenever you are writing a query, must present in the group clause. Let's say how many columns you are selecting in the select list? Department ID and the salary. What is the column which is used with aggregate function? Not used with aggregate function. Salary column is not used with aggregate function, and department ID column is used with aggregate function. Department ID column used with aggregate function. Sorry, department ID column is not used. That's why it must be repeated here. Okay, I repeat. Sorry for the confusion here. Okay, we have two columns which are selected in the select list. Okay. So first one is a department ID. Second one is a salary column. So salary column is part of aggregate function. Department ID is not part of aggregate function. So whichever the column is not part of any aggregate function must present in the group by clause. So let's say if I write the query, let me show you another example. Group by department ID. Let's say you have a job ID and total salary. So group by ID comma job ID. So here if I am using only the department ID and I'm selecting the job ID column, and if I do this query is syntactically wrong. It says that it is not a group by expression because you're selecting 3 columns in the select list, but only one is part of aggregate function. Remaining other 2 columns are not part of aggregate function. That must be present in the group by clause. Otherwise, this is a wrong query. You cannot use it. It throws the error saying that not a group by expression. So this way you can you can also group the data on a multiple columns. So how it works when you are grouping the data on a multiple columns. Okay, just concentrate here. So I have a data 10, and let's say I have a marketing manager and my salary is 10,000, and I have 10, let's say I have a marketing manager, so my salary is, let's say, 15,000, and I have 10, let's say, marketing representative. I'm taking only one department to be very simple. Marketing representative 5,000. So 10 again marketing rep, and then we have, let's say, 7,000. So now let's say I have to determine what is the total salary if I group the data based on the department ID and based on this one. So when you are calculating, so what will be the output of this? So if you see that first 2 rows, you are grouping the data based on these 2 columns. So when you see both of them, 10 marketing manager, so what will be the total salary? So the output will be 10, so marketing manager, and then the total salary will be 25,000, and 10 marketing representative, so total salary will be 12,000 what you use, 12,000 what you. So this way if you check it, it is basically groups the data with the similar columns. I mean 10 and marketing manager till this, which is a similar. So this way it will group the data based on the multiple columns. So even here also when you say that group by department ID comma job ID and the total salary, it will calculate like this. So what I'm trying to show you here is that you can also group the data more than one column. See, I need a response now. If I group only the data based on the department ID, what will be the total salary? Any guesses here? If I group the data, you can just ping me. if I group the data only based on the department ID, what will be my total salary? Yes, it is 37,000. So when you say that it's basically using only this one, so it is going to be 37,000. That is your group by, total salary. If you say that if you're using both of them, then you'll get the two rows. One is with a 10 marketing manager, 25,000. Another is 10 marketing rep, 12,000. So this is how your group by clause works. I hope everybody got the better idea here. Okay. So now one thing that you have to remember is that the columns which are present in the select list but not part of an aggregate function must be present in the group by clause. So this we have checked it. Basically, without using a group by clause, without using a group by department ID in the group by clause, if you use it, it will throw the error as a not a group by clause or a single to group function. And one more very important thing is that, let's say if you go by this query, okay, let's go by this query and calculate now. Let's say select department ID comma sum of the salary from employees group by department ID. Okay, let me answer, let me complete this. Okay, so when you say department ID and the total salary, what it is giving you? It is giving you the total number of, complete departments and their total salary. Let's say I want to understand only the departments for which we are paying the total salary more than $50,000. I want to understand that. So can I write something like this? So I hope you understand my question. Here we are identifying the departments and the total salary paid to that employee. But I need only the departments for which we are paying the total salary more than $50,000, 50. So can I write something like this? 50,000? No. Why? Because an aggregate function cannot be used within the where clause of the query. So if you try to see that, whenever you want to restrict the data based on the aggregate function, or whenever you want to filter the data based on the aggregate function, that aggregate function must be present in the group by having clause. So this is an invalid query. This is an invalid. So how can I write it in a better way? So one thing is, let me just copy paste to save the time here. So you are going to use a having clause to restrict the data. Having clause to restrict the data. When you say this, where having sum of salary is greater than 50,000. So when you try and execute, so this will give you the departments which are paying the salary more than 50,000. So this is how you can use the aggregate function. You can restrict the data based on the aggregate functions by using a having clause. So we have a couple of questions here. Let me just answer. Is there a condition that columns in the group by must be in the select list? Yes, it's a thumb rule and you have to follow that. That's a syntax. What I'm saying is, I repeat, when you are having a list of columns here, how many columns are there? Totally 3, right? So department ID, job ID, and the salary. So what I'm saying is, if a column which is not part of any aggregate function, so which are the columns are not using any aggregate functions here? So obviously the department ID and the job ID, that must be present in the group by clause. That must be. But vice versa is not correct. Let's say if I use select average of salary from, or instead of average salary, let's put it in the max salary, or okay, max of salary from employees. So group by GROUP, group by department ID. Is this a valid query? I need a response here. Is this a valid query when you write this way? Okay, so all right, so let's check. Yes, it's a valid query. So what did I say when I said that columns which are not present in the select list but not part of any aggregate function must be present in the group by clause, but vice versa is not correct. So when you say this, when you try to execute, it will work, because in my select list I have only the salary column, and that is using an aggregate function. So I can still use a department ID in my group by clause. I hope I have not confused you here. Okay. See, the columns which are present in the select list but not part of any aggregate function must be present in the group by clause, but you can have an extra column. Let's say it is also another way of writing this query is that you can also write in this way. Let's say I have getting the department ID, let's say this one, and I'm grouping the data based on this one. Is this a valid query? I need a response here. So yes, because so department ID and the salary, so both are actually there, and you are using a department ID here. If you try and execute this query is still valid. Okay. So one thing that it's only the one thing that you have to remember when you are using a group is that this is statement. That's it. Nothing else. If you remember that statement, it's everything else is very simple and you can use it. All right. So this way we will restrict the data based on this one. So if I give you a query, I want to find out the departments which are receiving the average salary more than 10,000, which are receiving the average salary more than 10,000. So how to write that query? It's that instead of sum, we have to use a average function. So here use the average. Let's say what value you have to decrease to 10,000. So when you try and execute this, this will give you the total, which departments are receiving the average salary more than that. All right. So this is completely about the aggregate function. We can also use the nested functions in the group by clause. Nested functions in the aggregate function. Now what do you mean by nested? Result of one function, you're passing it as a input to another function, that is called as a nested function, right? So let's try to execute this and check. Okay, so we'll go back to this example. So where are we here? Yes. So let's say, so if I use select max of salary group by department ID, what it will give me? It will give me the multiple maximum salaries according to the each department, right? So I want to find out the average maximum salary that I'm paying for each department. So I'll apply the average function on top of this. So can I use average function on top of this? Yes. So this is called as a nesting of the function. If you see, it will return me only one result. Can I apply the total function on top of it again? So if I write a query something like this, basically if I use this, it is calculating the maximum salary of each department, out of which it is giving me the average maximum salary. That is, it is nothing but a average maximum salary if I alias it. Okay. So this is giving me this. So can I apply the sum function on top of it again? Let's say the total value I want to compute it. Is this query is valid when I execute this query? No. Why? Because group function can be nested only to 2 levels, but your single row functions can be nested to n number of levels. See, your aggregate function is this. So if I try to execute the query, it says that functions nested too deeply. It says that group function nested too deeply, which means you cannot use the group function more than 2 levels. So this is a So one thing is you have to remember, group functions can be nested only to 2 levels, which you have. So this is more about the group functions and how you handle the data within the group functions. All right. We are done with the 4th chapter, that is about the group functions. Any questions here? You can go ahead. I hope it's pretty clear. Okay, anyway, I'll just wait for 30 seconds. If you have any questions, you can go ahead on this. Yeah.
Karthik, Ravi here. Always for group by we have to use having only, right? I mean,
Whenever you have to restrict the data, yes, you have to use having. Where clause cannot be used.
okay.
Okay. I had a question about the. I mean, I've got the question. Was going through the document and SQL found the substitution function, and where are you going to cover it later? No, I think substitution function is not required for you. It's basically for actually preparing the scripts and all. Not much useful. You can just leave it.
So we are just covering the basic SQL here, and whatever
We
is there
cannot,
part of
yes,
ISQ.
whichever is actually required for an Informatica Power Center developer, and I would say at most of it, not completely just by going it. So only the substitution operators we are not covering. Everything else we are covering as part of the syllabus.
Okay, thank you.
All right. So that is a fourth chapter that we have completed with. So the next one is about the joins. So see, so far if you see the queries, what we have actually written, all the queries are reading the data only from one table. What if I have to read the data from multiple tables? So how are you going to achieve it? So that can be achieved by using the joins. So joins are used to read the data from multiple tables. Read the data from multiple tables. So you need to make use of the joins. Now let's take a look at what are the tables that we are going to use here. We'll use a employees table. If you see it, anyway, you have the employees table here. You have all the employee details, and we are going to use a departments table, which is a department which contains details about the department, and you have a jobs table which will get the details about what is each job ID. Job ID is nothing but the designation, what is the title, and the minimum salary and the maximum salary. So these are the tables which we are going to use. One thing you have to remember is that whenever you are joining the two tables, you always have to join with a common column which is there. It is not necessary that common column which is present in both the tables, it should have the same name. Not required. It can be with a different name also. So in the department table, I can have it as a department ID. In employees table, I can have it as a DEPT ID also. So column name doesn't matter. It only matters with the data that is being stored. So whenever you're joining the columns, whenever you're joining the tables, you always join with the columns which has the similar data, So when you go here, let's say, let me just put it into the pane diagram to show you how we are going to join this. So I have a departments table which will contain all the details about the department. So what type of department it is and all. And you also have the another one that is your employees table, which will contain the details about all the employees. So we're going to use this here. So how are you going to join these two things? Predominantly we use this for most of the examples. So first one is your department ID. Department ID which you have. So departments and the employees both are joined with the department ID. And you have departments and even the location. Locations table basically contains the where and all you have the offices. I mean, organization has the offices. All those locations have been listed here. So if you have to join these two things, so it's going to be based on the location ID which it is there. Location ID which you have. And when you go with, I'm also going to talk about another type of a join called as a non-equi join. So it's basically we have a jobs table. So to join jobs table and the employees table, I'm going to make use of the salary column to join the data. So we'll also talk about this. So these are all the different tables we are going to use in this example. So basically department ID, location ID, and the salary column and all. So let me just try to show you now how to read the data. See, my first requirement, when we talk about joins are of different types. And when you're representing a joins can be written in the ANSI syntax or in the general syntax as well. So as syntax, or you can also use general syntax to do this. So let's pretty much ANSI syntax or the general syntax what you have. So first we'll take a look at how the ANSI syntax can be written, then we'll go for a general syntax what you have. Okay, so joins are of different types. Broadly, joins are classified into two types. One is a equi-join, another is a non-equi-join. When you say equi-join means, equi-join is nothing but when you are joining the two tables, if you are using the equal to operator, that is called as a equi-join. When you say non-equi-join, if you are using the other than equal to, let's say greater than or equal to, comma, less than or equal to, or not equal to between the two tables, then that join condition is called as a non-equi-join. And that is a one classification which we have. Okay. Other classification is that based on the data that is being retrieved. Okay. So we have a different types of joins, inner join, and under inner join you have a different types again. So let's talk about inner join, outer join. So under outer join you have a three different types. So one is a left outer join, and another is called as a right outer join, and you also call it as a full outer join. This is the one, left outer, right outer, and the full outer join. And you also have something called as a Cartesian join or a cross join. So you call that as a cross join. This is also another one. You have one more join which is a type of an inner join, but it is not a this is called as a self join. So this is another join condition which you have. Okay, so now we'll talk about one by one how each join works. Let me come back to inner join first. See, whenever you're joining the two tables or any number of tables that may be, okay, when you're joining the tables, if using an inner join, it will give you the matching data between the two tables, whether it is an equi-join or non-equi-join, anything is fine. So matching data between the tables based on the join condition, So now let's try to write an inner join. Concentrate here. So when we have a department table and the employees table, basically my requirement is that I need to display the department ID as well as the department name, and I also want to display the name of an employee, job ID of an employee, and the salary of an employee, which is coming from the employees table, and if you say that it is coming from the departments table. Okay, so let me write the query. Okay, select from what are the tables that you are using here. So first table is departments. I can alias the tables, in the sense instead of using it I can just alias it as a D. So inner join, so you're joining this table with what? Employees table to fetch the employees data, employees. So I'm going to give it as a E. So whenever you're specifying a condition, you should use a keyword called as a on basis of what condition you're joining both the tables. So what is a column which is common between this? If you look at hello?
Okay.
Yeah, one second. I think there is some network glitch. I think it is moving now, right? Screen. I think you're good now. You guys must be good. Okay.
Yeah. Yep.
Yeah. Okay. Thank you.
Yeah,
So
now
yes. Thank you. So when you say that you're joining based on the condition, it's nothing but a. So instead of using a complete table name, I'm using here department ID, d dot department ID equal to e dot department underscore ID. So I'm joining both the tables based on this condition. So this is my condition. I'm joining a department table with the employees table based on the condition. Why I am prefixing with the department ID, prefixing with a D is because I aliased it. If you're not aliasing, you have to use a fully qualified table name. Okay. Here, what are the columns that you want to bring it from the department table? I need a department ID. So I'll call this as a D underscore department ID. Let's say D dot department name, D dot department name. And from the employee table, I think you need a E dot last name. Okay. Let's say E dot job ID. And you also need a E dot salary. So this is my data. So let's consider this. When I execute this, based on these two conditions, it will give me the matching data. So before we go to this, I just want to give you the clear explanation how the join works. Concentrate here. Okay. Let's say I have the department details. I have something called as a 10, let's say HR, and 20. We'll take very simple records. We have so many things here. Let's take administration, this one. So I have a departments table. This is my department table. If you see, this is my department ID and this is my department name. I'm not worried about other columns what I have. Leave about it. Okay. And go back to the employees table. So if you see that employees table, let's take even the another department. Okay. 30. Let's call it as a finance. So in employees table, I have these data. My employee ID is 100. Let's leave about even the employee ID is, I don't require that. So let's say you have the details. So Chakri, and basically Chakri, and then the salary is, let's say, 25,000. And what else you need? Salary and the job ID, right? So this is president. And the department ID which we have, will use one more department here. So something called as a manager department. Okay. So this guy is belongs to the manager department. And you have another one, let's say Santosh, and salary is same. And probably this guy is AD underscore VP. And you have the date as a 90. And you have, let's say Vanita, and you have some 10,000. Let's say human resource. So I call it as, let's say, HR rep. Okay. And this data is belongs to 10. And you have admin, let's say Ishwar, and let's say 0800. And since this guy is admin, so I call it as admin rep, AD underscore rep, otherwise representative. So this is going to be the 20 department. And I have this another one, let's say Karthik. So 6,000. And let's say IT programmer, you call it as an IT programmer, and there is no department assigned to Karthik. Similarly, let's say you have Rajesh and 07,000, and this guy is also an IT programmer, but this guy also doesn't have any department associated with it. Okay, so this is your data. I hope you're good till this point. Okay, so this is my employee name, and this is the salary, job ID, and the department ID, what is represented. So how we are joining this and this based on this column and this column. All right. So when you join the data based on this column, when you say that department with employee, so what it will do is it will go and fetch the first record from the department table. Okay. So I'm talking about an inner join, how this works. Okay. It will go and pick the first record from the first table, And then what is the condition that you have matched with this? It will go and match with this condition. So when it is matching with this condition, is 10 equal to 90 is true or false? False. So since this condition is false, this record will not be retrieved. And 10 equal to 90 true, false. 10 equal to 10, yes, it's a true. What are we fetching here? We are fetching the 10. Department name is HR. What is the employee name? Employee name is Vanita. And then the HR representative. Let's say even if you would like to get the salary here, 10,000 and then HR representative. Is 10 equal to 20 false or true? It is also a false condition. And 10 equal to null. Obviously you cannot compare any value with a null. It will be evaluated to null. So even these two records will not be retrieved when you are matching with this. Null equal to 10, null equal to 10, which obviously will be evaluated to null. These records also will not be retrieved. So when I matched with the first record, I got only this record because it is only the matching record for me which it has given, right? So let's move on to the second row. We talked about only the first row, how it worked. Let's move on to the second row. 20, is 20 equal to 90 true? False. 20 equal to 90 true? False. 20 equal to 10 true? False. 20 equal to 10? Yes. So here you're going to get 20. Let's say I'm not representing the full name. Maybe you can understand this. Admin. Let's say Ishwar. And if you go on with the salary is 8,000. And what is the job ID? It's going to be the admin rep. Is 20 equal to null is true or false? Obviously it will be evaluated to null. So these records also will not be retrieved. Move on to the 30. So 30 with 90 false. 30 equal to 90 false. 30 equal to 10 false. 30 equal to 20 false. 30 equal to this false false. So that means 30 department doesn't have any matching record in the employees table. So this department will not be retrieved for you in the end result. Next, go for a 90. Is 90 equal to 90 true? So these records also will be retrieved. Let's say the department name is manager and you have the employee name is Chakri. Let's say, so when you go here, the salary is 25,000 and let's say president. And you have again a 90, so which is a manager department, and you have the Santosh, so the salary is same 25,000, but this is a AD underscore VP. So when you say this here, yes. So now I got a question here. So will inner join match the two null values? Can anybody answer this? Will inner join match the two null values? According to our data? No, absolutely not. See, when I actually matched, I clearly said when null equal to 10 or this, it will be evaluated to null. So that is the reason we are not getting these two records. Did you get that in my inner join record? No, absolutely not. So it will match only the data whenever it is that condition is evaluated to true. When you say null equal to 10 or null equal to 20, it will not match the data. So that way inner join works. I hope everybody got this. See, it's a very simple thing that you have to understand is that how the join will be evaluated. Remaining all the other joins are pretty simple. So if you have any questions, I'll repeat this what we have discussed here. Then your left outer join, inner join, anything is very simple. You don't need to worry at all. So any questions here? Okay. Right. So now when I go and, okay, my question is department ID has a null in department ID. So if you go for this, let's say I have a null and you go with, it works in the same way. Now when I call this as, let's say, what department you can call SCM, supply chain management. Okay, you take the null value. Is null equal to 90? True or false? It is evaluated to null, which means it doesn't give you the record. If you say that null equal to 90 again, it is evaluated to null. It means it doesn't give you the record again. So let's say if you say that null equal to 10, which is again evaluated to null, it doesn't give you the record. 20, is null equal to null is true or false? This is a good question. Is null equal to null is true or false? False. Yes, very good. What happens, you cannot compare anything with a null value. See, when we talked about equal to null, did we say that equal to null will work in SQL? We did discuss about is null. Whenever you have to say that is null, you have to use it. Null cannot be compared with any other value. Do remember, null cannot. So when you say that null equal to null also, that is not true. It is evaluated to null only. It is not true. So even when you say null equal to null, it is evaluated to null. So these records again will not be retrieved. Even in that case also, this department and this department won't be retrieved for you, right? So that way it works. I hope I cleared your question, Priyanka, now. Right. So this is your inner join. So when I execute this, it gives me the matching data between the two tables. So now let's go on check. So how many employees are there in employees table? Total 108 employees are there, but we have retrieved only 106. What happened to other two guys? Let's go and check. So if you see, the department ID here is null for one employee. This guy is, I don't know what is his name, Chris 240. Okay, that's fine. And there is another employee who doesn't have any department associated with him. So this is another employee. So these two employees have not been retrieved for you. Let's go on to the department table. So if you see, department has from 10 to 270 departments, right? Let's go here. So if you see the department details, you got only from 10 to 110. What happened to the other departments? From 120 to 270. What happened to these? These departments doesn't have a matching employees in the employee table. So definitely these will not be retrieved. So only 110 till 110 it will be retrieved. 120 to this is not retrieved, which means it doesn't have a, let me collapse it. So it doesn't have a matching records, which it is there. So that is a use of an inner join. So inner join works in this way. All right. So I hope everybody is good here. Let's move on to the left outer join. So when you say that left outer join, it will give you the matching data between the two tables. It will give you the matching data between the two tables plus unmatching data from the left table. Unmatching data from left table. So how would I use it? Same query, instead of an inner join, just use left outer join. That's it. So what is a left table here? Is it a department or an employee? Left table, when you say that departments, it's a department, right? So departments D join with left outer join, employees E, so it is joined with a department and an employee, so left table. So it will give me the matching data between the two tables and unmatching data from the left table. So let's go on here. Let's write a left outer join, how it works. So left outer join. So what is a matching data? Obviously this is a complete matching data what you have. And what is a unmatching data here? So 30 department doesn't have a unmatching. So what you are going to be? So 30 finance. What will be the employee attributes? Yes, here is an interesting question. So now when I represent null, yes, definitely it will be null because it doesn't have any matching data here. So it will be null for completely. I'm not representing a null value. So what about this record? Will this be retrieved? Null equal to SEM? Yes. It will still display that record. So null, and this is going to be, I mean, null means there is nothing. So let's say I call it as an SEM. So this is an unmatching data based on this. So when you try to execute, earlier what happened was your 120 to 270 department were not retrieved because it doesn't have a matching record. Now let me use that with a left outer join. So when you say that, if you go on, see here from 120 to 270, these values have been retrieved, and your last name job ID is being retrieved as a null because it doesn't have a matching record in the employees table. So this record will be retrieved as a null. So what about a right outer join? See, basically I think you're good with left outer join. So when you go with right outer join here, so right outer join, so basically right outer join gives you the matching data plus unmatching data from the right table. What is the right table here? Unmatching data from the right table. So your right table is nothing but your employee table. So when you try to use it, so Control C, let's say your employees right outer join. So if you see this is an unmatching data from the right table. This Grant and Chris are the two guys, they are not mapped to any of the department. So that's why we are getting this data from the right outer join. So this is one more thing about the right outer join in using this. So the other one is about the full outer join. So when you say full outer join will give you the matching as well as an unmatching data. So matching plus unmatching data from both the tables. So when you say unmatching data, it will give you the unmatching data from department, that is your 120 to 270, and it will also give you these two employees, both of them. So for a department matching data, you'll have an employee as a null, another way it is a null value. So how do you use full outer join? So when you say here, so let's try to use full outer join. So try to use this. So if you see, these are all the, let me just scroll it down here. So these are all the unmatching data from the department. So let me scroll it up and show you we have a larger data set here. Okay. Okay, these are all the departments which does not have any employees matching, and these are all the employees who does not have any matching. So it will give you both of them. So if you see this here, when you say the right outer join, it basically gives you the unmatching data from your this table. So Control C, and this, who are all the unmatching employees? So it's basically the Karthik and the Rajesh. So if you see Karthik and 06,000, let's say you have an IT programmer, and let's say Rajesh, let's say 07,000, and you have an IT programmer. So this is here. And when you say full outer join, it's basically the combination of both of them. So full outer join will work in this way. Full outer join. So when you try to write it, let's say this complete data it gives plus this complete data it will give you. So that is your full outer join. Joining unmatching data from both the tables that will be retrieved. So this is very important. Joins are very, very, very important. So any query in real time, you use a join and then write it. We simply do not retrieve the data only from a single table. So that is your full outer join. So let's talk about, can I join more than one table? Yes, you can join more than one table. So if I use, more than one table in the sense, I mean to say more than two tables. Okay. So here, if I have to bring in even the location details also, so how could I join this? So basically, if I have to include another table, which I call it as a locations, which I call it as L. This also I'm using an inner join. Let's say on D dot location ID is equal to L dot location ID. Let's say we have a city column in the location, so I'm bringing the L dot city, so which you can use it. Inner join, it should be here. Inner join with locations L and then write it. So this will give you. Can I use a where clause? I want to retrieve only the employees who sits in South San Francisco. So I can even write a where clause here. I can write it as where L dot city equal to this. So when you try to use this, try to execute. So this will give you the L dot city, and when you try to use, total 45 employees are sitting who are in the South San Francisco. So this way you can write even you can join more than one table as well. All right. So what do you mean by a non-equi-join? All these, so are these joins are equi-joins or non-equi-joins? All these are all the equi-joins because you're using an equal to operator in between all these when you're matching the data. So these are equi-joins. What do you mean by a non-equi-join? Let me write a query. So select from, let's say, employees table, let's say inner join itself. I'm using an inner join, which means it will give me the matching data. Jobs, let's say J, and what is the condition? That is going to be the E dot salary is greater than or equal to J dot minimum salary. Let's say we have this column and E dot salary is less than or equal to J dot max salary, which it is there. So when you go here, E dot last name, let's say E dot salary and J dot job ID and J dot minimum salary, and you call it as J dot max salary. So when you try to execute this, so it's basically, it will give you the complete details about what it is. So when let's take one example. If you see the able who is receiving a salary as 11,000 is being repeated for 6 times. So how it works? Let's go to the employees table and jobs table. We'll clearly understand. Okay, let me just sort it on the last name column. What is this guy's salary? This guy's salary is 11,000, right? So it will take 11,000 and it will go to the jobs table. What is the condition that we have written? If you see that, we have written a condition as its salary is between the minimum salary and maximum salary. That is what I written. It's basically using greater than and less than or equal to. Instead of using between and, I have used greater than or equal to, less than or equal to. It works in the same way, which is like E dot salary is greater than minimum salary means. So if you go to job, is 11,000 exist between these two records? No. Does 11,000 falls between 15,000 and 30,000? No. Is 11,000 falls between 3,000 and 6,000? No. Is 11,000 is between 8,200 and 16,000? Yes. This is one record. That's why if you go and see, finance manager would have been qualified. So he is qualified to work as a finance manager. See, this is a record. 5th record is that only. And similarly, if you go on matching the data, another 8,200, 16,000, he is qualified to even work as a account manager based on his salary. So account manager is being retrieved. So likewise, if you go on matching the data, 8,000, 10,000 and 20,800, he is qualified to work even as a sales manager. So his salary fits onto that zone as well. So when you say that, and similar thing, 6,000, 12,008, yes, he can even work as a sales representative according to his salary. So this is also there. And similarly, the peon manager and the marketing manager. So this is one match which you have. Another match is this as a peon manager. So, sorry, it's purchasing manager. Okay. So it's basically it is matches with all the records, and it will give you the matching data only according to the condition what you have written. So why it is called as a non-equi join is only the reason is that you're using the greater than or equal to, less than or equal to symbols in using this. So that is more on the that is more on the non-equi join. Oh, sorry, non-equi join. And next one is about the self join. Self join means if you are joining the single table to itself is called as a self join. Okay, let's say now I have, let's go on to data. So this is little tricky, you have to concentrate here. Okay, when you go to the employee table, in employee table I have an employee, and I also have a manager who is actually manager of this guy. I want to get this somewhere here. Okay, so let me check this one. Okay, so basically when you say that employee ID 174 and 149 is a manager ID, what does that mean? It basically that 149 is a manager of this employee. So who is 149 here? So if you just sort it, 149 is this, 149 is this. So this guy is a manager of that employee. So likewise, it is manager ID is nothing but the employee ID of your manager. In an organization, we'll store a parent-child relationship something like this. Let's say if I represent into the Venn diagram, okay, so you have employee 100 who is the president of the company, and this guy, for him there are two employees who are reporting to him. Let's say 101 and 102. So 101 and you have 102 as well. So try to get this, and when you use it, let's say 101 and 102, and you're associating, I mean this guy, and 101 probably managing maybe other two employees as well, right? So 103 as well as 104, 103 and 104, basically you have even this also. So when you are storing the parent-child relationship, basically for 100 he doesn't have any manager because he is the boss. So he doesn't have a manager whom he reports. So that's why for 100 the manager ID is null, means no manager for him. So for 101 and 102 are reporting to 100, and 103, 104 are reporting to 102 and 103. So likewise the parent-child relationship will be stored within the same table itself. You won't store a manager information in one table and the employee information in one table in the RDBMS. So generally we store it in the same way. So now how do we, I need to get what is the manager name and how many employees are actually reporting to that manager. So when you write it, select from, concentrate here, I'm using the same table, employees E, inner join or outer join, whatever it may be. Inner join means it gives only the matching data. So I'm giving as employees M. So what is the join condition here? I'm going to write, let's say manager ID from this table is matched with employee ID of this table. So when you say this, E dot manager ID is equal to M dot employee ID. So when you retrieve this, you'll get all the employee details. When you retrieve this, you'll get all the manager details. Let's say if I use M dot last name, it is nothing but the manager name. So alias this with the manager name. Let's say M dot salary. I don't want M dot salary. Let's say basically M dot job ID. So I want to retrieve this. So this is nothing but your manager job. And when you say that E dot last name, that is nothing but the employee name, and I want E dot salary and E dot job ID. So this is nothing but the employee job ID. So when you try and retrieve this, so why it is called as a self join is because you're joining the same table to itself. So that's why it is called as a self join. So if you want to understand how many employees are actually reporting to King, so how would you get that? So m dot last name is equal to King. So for King, how many employees are being reported? So when you try to execute this, so this will give you the complete data in using this. So you have for a King, these are all the employees who are being reported into this. Hestin, Kocher and all. So these guys are marketing managers are reporting, vice presidents, purchasing manager, sales managers and all, everybody is reporting to him. So this is called as a self join. If you're joining the table to itself, that's more on the self join part. So probably you have to analyze the data to get a complete understanding how the self join works. So if you see this, our example, if I try to write it, let's say Chakri has an employee ID. Let's say 100 is employee ID, and this guy is also 101, and let's say 102 and 103, and let's take till this part. And Chakri doesn't have any manager because he's a MD. And when you say that this guy is reporting to Chakri, and this team is also reporting to Chakri, and even Ishwar is actually reporting to Chakri in using it. So when you say that 100 equal to this, so basically if I want to know how many employees are actually reporting to Chakri, so basically I can easily understand Santosh, Vanita and Ishwar. So in this way it is more on the manager parent-child relationship. Basically in the manager ID column you're storing it. So if you want to get this data through the self join, if I want to get the manager name and then the manager name and then the employee details, so it's basically it will give you Chakri, and then who is actually, this is manager name, and who is reporting to him, Santosh, and what is his salary, 25,000, and Chakri, again this will be repeated, and let's say Vanita, so this is your 10,000, so Chakri, Ishwar, 8,000. So likewise the self join will help you to retrieve the data from the same table. So the last join which we are going to talk about is a cross join. So how do you use a cross join or a Cartesian join? So let's say if I use select from employees cross join on departments. So departments D, let's say. So cross join means it's basically try to match the data with each and every row and then it will display it. Basically if you're not providing any join condition, that becomes a cross join. So when you go here, let's say I want E as well as and department D. So if you use here E dot last name, let's say E dot salary, and I call it as D dot department name. So when you try to execute, how it will work is, since you have not defined any condition, it will try to match the data with every column. So basically you don't have any matching condition, it will try to match for every department. So if you see, if I sort the data by last name, this able would have been repeated for 27 records. Why? Because you have 27 records in the department table. So it will try to match with every record and it will try to basically club with every record. It doesn't have any data. So when you say that if employee table is having 108 records and department table is having 27 records, the total number of records written by this query should be equal to this from, let's say, dual. So when you try to execute, so this query would have written 2916 record. Let's check that. So it basically gives you m by n rows, 2916. It tries to match with every record. So that's why Abel is being repeated for 27 times, and A is repeated for 27, Atkinson, Austin, likewise. It repeats for every record. So cross join will always give you m by n rows. If employee table is having m rows and department table is having n rows, it always gives you the m by n rows. One important thing you have to remember with joins is that whenever you are joining multiple tables, let's say if I am joining n tables, n minus 1 joins are minimum. N tables, n minus 1 joins are minimum that you have to use. If you are not using n minus 1 number, basically if you are joining 3 tables, 2 join conditions are minimum. If you are not using it, it goes for a Cartesian join. So in which scenario we can use a cross join? Basically, suppose let's say I have an order table, or yes, if you have to find out the permutations and combinations, let's say I have an order table which contains all the order details and which product has been purchased, or you can call it as this as an order item table, and I have a product table which contains all the product details. So it basically, if I have to find out the query is like how order can be created. So how many permutations and combinations? This is basically little bit of an analytical query that we are talking about by use of the cross join. Let's say if I have to understand basically if I have to understand what is the query, what is the product which has been sold on every January 1st, if I have to get that, some kind of a very complicated analytical queries, we have to derive that based on the cross join. But unless and all, most of the time we'll use an inner join and outer join as well. We don't go for a cross join. Cross join, we can't say it as a disadvantageous. Let's say if I have an order table, let me put it in this way otherwise. So if I have an order table and if I have a product table, what are the what are the different ways that I can create order based on the how many number of products? So it's something like O1 P1. Basically if I use capital O1 product P1, O1 product P2. So what are the different combination that I can create the order? So O1 product P3, O1 P4, something like that. So if you try to represent, so then if I have to understand how many orders contain the product P1, then I can easily get that. So this is let's say O2 P1 and let's say O2 and then P2. So now out of all these orders, I want to understand which is the product which contains the product P1. Basically P1 is referred by how many products. P1 is purchased in how many orders, so that can be determined. So basically if you have to determine some kind of a data mining, it's basically if you stepping onto the analytical environment, so you have various permutations and combinations to check. In those cases your cross join will help you to determine. So this is your cross join, which it works. So we have I need just 5 minutes of your time. We can wind up here. So basically I just want to show you how general syntax works. So general syntax is pretty simple. It's that we don't use any keywords in the general syntax. So whenever you're keeping the list of table names, just separate all of them by the comma and keep all the conditions in the where clause of the query. Where clause of the query. So when you try to execute, so this will give you the same result. Result wise it's the same, but if you are using left outer join and right outer join, how do you represent left outer join and right outer join? So basically if you are keeping the plus symbol on the right hand side, that becomes a right outer join. Let's say plus and keep this one here and use the where clause of the query. So try to, where did I write? I think I'm changing it in a different place. Okay. So you need to write a plus symbol here. So that will give you the left outer join. So when you try to use it, and if you are keeping a plus symbol on the right hand side, that becomes, left hand side, that becomes a right outer join. So I'm going to send you this file anyway. You can cross check how general syntax will be written. When we go to the Power Center, we'll write all the general syntaxes only. I don't use any ANSI syntaxes. So even that time you can get to know. Full outer join is not possible in the general syntax. So don't try to keep the plus symbol on the both the sides and execute the query. Full outer join is not possible. And when you say a cross join, it's pretty much simple again. Cross join is that you just don't use a keyword and just replace that. So try to execute this. So this how it can be done. So this is more on the joins part and the aggregate functions. So basically probably I'll just try to attach this when I'm sending a video today. So probably that will be helpful for you. Okay, so any other questions here before we sign off for the day?
Karthik, I have a question.
Yes.
So when we'll be using virtual machine setup, will we be able to use this database later, or we will need connection?
No, virtual machine is basically